Hello. Wow, that's cool. So it's a little bit louder, but that I think that's cool after eating. Okay, so we will continue now with Ionut Codreanu, who is lead programmer at Ubisoft. And Ionut is a passionate game developer experienced in mobile and online games. And he will talk about improving reliability in online games. And even though we're talking about online games, I think Ionut will talk about a way of developing software that they are using there in order to have reliability. And I think we can all have some insights from his presentation. So, Ionut?
Hello, welcome back. So your energy level is probably low. Mine is the same, but I think we can overcome this small bump. Improving reliability. Just wait for the slide. Okay, pompous name, not such a pompous presentation. We'll just talk about how we can change the way we develop in order to have more stability and in order to be able to deploy things faster and with less rate of problems. A few things about me. I'm a programmer at heart. I started with game development, and I am still doing that. I am very passionate about product quality, and lately, in the last couple of years, I've been starting to pursue management challenges, and I really like it. During my free time, I like to play video games and go out with friends. How many of you are game developers here? 1, 2. Okay, and there are a few there because they're my colleagues. Any of you developing online games? Okay. Online software? Great. So this will probably be something different from the way you do things, but I think there will be some insights that you might find interesting. What you should expect from this talk. We're going to talk about games and the way we develop them. We're going to talk about gaming as a service and how we can improve the reliability of these services. We are not going to talk about in-depth technical stuff, and we won't have any code snippets. We can talk about it later if you want. So games. Not later than yesterday, I was talking to Patrick. He had a talk earlier. And everybody thinks that game development is totally different than software development. They think that there are a lot of particularities to it. First of all, the implementation difficulty seems to be way bigger if you are developing games. But that's not always true. If you are developing a search engine, you will most likely have difficult stuff to take care of and difficult algorithm to develop. Also, team variety. Here, I could say that this is true. You have art department, you have design, specialized programming, and more exotic job families like cinematics or audio design. But you also have a lot of departments when building an OS, for example. The scale of the projects. GTA 5 reached $165 million as costs for development, and at its peak, it had 1,000 developers. Now, those are big numbers, but not all games are that large. Then you have the quality standards. In terms of quality standards, games are, let's say, the harshest thing that you can develop. You need to really put a lot of effort into eliminating all types of bugs because your users are just not used to bugs, used to crashes, and they will quit your game. If you have an application, your user will probably reload your page, and that will be it. There are two things that are really important in game development. predictability. So you cannot predict how your application will be implemented for the whole development life cycle, because things will change. You need to measure fun, and that is not always easy. Actually, that is never easy. And the second one, and we are going to cover this more during today's talk, games are performance bound. Your architecture needs to suffer sometimes in order for you to have the best quality and the best performance possible. So let's say that you're developing a game. You have a company, you are developing a game. You will most likely use this process. You will go to in pre-production, have some concepts, game design document. You will do prototypes, build your tools, and establish your plan for your development. Afterwards, you're going to go to implementation, to production. Here, you may or may not change your design. You will reschedule. You will add new features, remove some of them. And in terms of development, you will use waterfall, agile. I know there was a talk about agile earlier. In game development, we usually use parts of agile. We don't use it by the book. And afterwards, you will launch. If your game is successful, you will probably have patches. You do updates and add new features, maybe offer some support. OK, this is for a normal game. But then we have the connected era. And you add a new layer of technology, network. You have play together, but you do not have any persistence. Maybe some leaderboards, but that's not really persistence. This doesn't bring any new parts in your software development process. You can build the same, you can release the same, and you offer the same support afterwards. But you want to take it to the next level, and you want to build an MMO. The particular thing about MMOs are that they need a persistent game world, and they need to be always online. This brings two new challenges. You need to have the game up and running, and your uptime is critical. And you need to push updates regularly. You need to add new features. You need to keep the game alive in order to keep the momentum and keep the players engaged. And you can have marketing and whatever for player retention. But what is critical is that you can add new features in order to keep the player retention. So what does your new production cycle look like? You go into pre-production, you develop the game, go into production, and then you launch it. After you launch it, you will gather feedback from your users. You will implement new features and address any issues that appear during the online part of the game. And you will release again. And you will go into an infinite cycle of doing this. So the post-production will become just a cycle of this mini production development cycles. You have new complexity, and this will bring you a lot of new problems. Before you address this MMO, your game stability was your main issue. You need to push bug fixes, you need to add new features, implement improvements. When going to an MMO, you have a lot of new problems with the features because your game complexity increases, and so you have a lot of new features that can cause you bugs. Besides this, you have new technology that will bring you communication problems, will give you server performance issues. Your game needs to be scalable in terms of database, of persistency. And you also have external APIs that may cause your game to crash. And on top of all of these, you will need to push a lot of features and a lot of updates regularly. So what do you do? Your new business environment needs you to develop and deploy at the same time. So you have a game that's been developed, and you have an online software application that needs to have regular updates. Your requirements are to have a fast iteration and deploy every whatever weeks, let's say couple of weeks. That's actually long, considering what Patrick said earlier, but I think 2 weeks is good for development and deployment. You need to have the possibility to exclude some of the features that are not finished yet, and you want to avoid code freezes, because you want all your developers to work while you deploy. So what can you do? Your current status is that you are using continuous integration, you are using unit tests, but this does not assure you that your game will work in a live environment and that you can push updates regularly. So what can you do? You can change the way that you develop. Yeah. It's blocked. Just a sec. The clicker. Yeah, just a sec. Yeah. It went on standby. Nope. We have a little bit of a problem here. Nu mai merge clipul.
Ce nu merge asta?
Mhm.
Apăsat aici, nu trebuie să apeși aici. Deci pe astea nu apeși. Înțelegi? Nu apeși pe astea.
Okay.
Doar pe astea.
Photo? Okay. Too many buttons for me. Sorry about that. So you change the way you develop. Basic trunk-based development will tell you that you develop in your trunk. Every developer pushes its commits to the master branch, and you'll have everything in your trunk. How do you deploy? You can deploy in a couple of ways. The first one is using feature toggles, the methodology that continuous delivery is sustaining. So just prepare your trunk for live development, you enable or disable some of the features, and then you deploy, you make your release version. It has its pros, like low organizational overhead, and your conflicts are identified fast during development. But the cons, if you want to have an always online game, is that you will have a long stabilization phase because you have uncompleted features, and these uncompleted features can cause problems on the live systems, on the already functional features. You can also use cherry picking. I think this is even worse. So you have a release branch, you have your master branch, you pick out features, and you regularly update your release branch. You have the same pros, but you have only fully tested features. The cons would be that you need a lot of time to build a release version, and that your versions diverge because you have no common code base for releases. So how about we do things differently? We commit to having a stable trunk, and we develop everything in feature branches. Patrick's going to kill me for this. So each of your features will start to be developed in a different branch, and then when you are ready to deploy on a totally different track than development, you decide to get your already functional and tested features and add them to a release version. And if this fails, if one of the features does not work, it is as simple as not adding one of the features in your release version. So let's take a look at how the process might work. So you have two different tracks. You have your development track and you have your deploy track. Your deployment track will be based on your stable trunk, and you will add your features as they are finished to implement, and they are ready to be shipped. I'm just going to leave the picture for 2 more seconds. You can have any number of programmers in any number of different countries working on different features, and only one team that handles deployment and version merging. So this is a way that a method that you can use in order to have a better stability for your trunk. So you change the way you develop. How about the pros? You have a fast creation of a release version. Your version will only contain fully tested features. Your QA can start working on them even before they are finished, as opposed to having them in the main branch with a feature toggle. And you will be able to plan ahead all your conflict resolutions, because you decide when you will deploy and when you do the merging. You don't have to merge your changes to the trunk every time you submit something. As cons, you'll have higher overhead during deployment. Your merge conflicts will be identified when you build a release version, and also you need someone to manage all your feature dependencies. So you change the way you develop. You can also do something with the way you deploy. As 2 common best practices, you can use staging servers, and you definitely need to have rollback support. Multi-stage deployment. Yeah, I think I broke this again. It's OK. So you need to have at least 1 staging server where you can test all your changes before you launch them on live, in production. And the server structure needs to be as close to the live system as possible, because different configuration can cause stability issues once you launch. Also, if you afford to have multiple servers, it would be good to have servers for automated tests, for load tests, for quality control, and even better if you can afford a beta testing server. The second thing you can do about deployment, and the most important, is to be prepared for when it crashes on live. And it will crash. Even if it passes all your validations, at some point you will have a fail on live. And when you do, the best thing to have is a backup. So you need to be able to roll back as soon as possible, and you need to be able to roll back just the features, not the player progression. When you have monetization, let's say an hour or 2 on live means that people invested money in your game, and you cannot roll back their purchases. In order to have this in place, you need to have your developers think this way. So each feature needs to be developed with this in mind, with the possibility of rolling back your progress. So if everything else fails, it would be good if you have community management. This can ease up your problems with the community. So what are the key takeaways? Games. When you think about games, don't think about different software. It's just as good as any other software, and the development processes are nearly the same with any commercial software. The one thing that you should remember is that you need to make architecture compromises in order to have the best performance you can get from the platform. The fast update cycle that was imposed by moving to online, by moving to these persistent game worlds, pushed the online games towards a games as a service model. And in this games as a service model, we needed to adapt to reliability, and we need to have games that are continuously functional and that can reach players in in any corner of the world and at any time. Two ways of improving that reliability. First, to change the way you develop and try to implement a feature-based approach that works very well if you have distributed teams. And the second, change the way that you deploy, add staging servers, and have a backup plan for whenever. And the main thing that you need to remember is that no model, however perfect it says it is the best. You need to adapt your development cycle to your needs. If you have problems with the architecture, then you need to have a system in place to protect you from any faulty commits. If you have a good architecture, then maybe continuous delivery with trunk-based development is the thing for you. But the main thing to do is to think about what you need from your system, what your problems are, and then choose how you develop and how you deploy. This being said, I can take any questions, and hopefully I have an answer for you.
So you mentioned being able to roll back when something goes bad. Yeah. How do you handle the nasty case when something goes bad in the database? For example, like you messed up some things badly.
That's the worst case scenario. So if that goes bad, you need to have a system in place to roll back the database. But this is like the last resort. If not, if you develop with this in mind, and you have like modular approach for each player, and you can do queries to find out where it broke, you can then roll back individual parts of the database. This is how we did it. So whenever we added some info for a player, we added support for rollback. So we have scripts in the backend that allows us to extract all the info for one player, and then unfortunately we manually check it. But it happens, it doesn't happen so often, so that's okay. Yeah.
So you said that each feature is worked on a different branch, and you had two-week releases or something like that.
Yeah.
And when a branch with the features was done, you merged it and it was part of the release. But I saw in that chart that each week or each 2 weeks, you also had the bug fixes as part of the release.
Yes.
Where are the bug fixes done? In the trunk, or do they have a separate branch?
Yeah, that's a good question. So there are two ways you can do this. The way we decided to do it is to go with feature branches, even for bug fixes. But when the bug fixes were really small, we would just branch on one, only branch one for one bug fix, and then add the other bug fixes on top of that. So if it's on a case-by-case scenario, but we never, absolutely never push in the stable trunk. The stable trunk can be used at any point to generate version. If we decide to create a version for, I don't know, a new server, a new site, we can go with the stable trunk and just push new features. Maybe we develop a special feature for a special provider, and then we can just grab the stable trunk and add that feature. So nothing is done in the trunk.
More questions?
No, I think that's it.
Okay.
So thank you.
Thank you, Ionut.